Hello everyone. In this video we're going to be solving a polynomial system, a cubic polynomial system. We have x cubed plus y cubed plus z cubed is equal to negative 48, x squared plus y squared plus z squared is equal to 24, and xyz is equal to negative 16. So you might be guessing the possible solutions at this point, but let's go ahead and solve this system. I'll be presenting two methods, and let's start with the first one. So for my first method, I'm going to use substitution. Since I don't know the sum, x plus y plus z, I want to call that something, how about s? And then I'm going to square both sides. When I do, like this, I'll end up with something like this, x squared plus y squared plus z squared plus 2 times the quantity xy plus xz plus yz is equal to s squared. Now this is good because I do know x squared plus y squared plus z squared, that is equal to 24. And that actually allows me to write the two-way sums in terms of s. So from here, if you solve for xy plus xz plus yz, you'll get s squared minus 24 divided by 2. So that's one of the things that I'll be using later on. Let's go ahead and save it for future use. And then take a look at this problem from another perspective. Since I have the sum of cubes, it makes sense if you cube the expression, right? The x plus y plus z. But when you cube it, you have to be careful because you're going to get a lot of terms here, right? So this is going to be a trinomial expansion, not binomial. But there is a really nice identity. I don't know if we talked about this before. We probably didn't. But anyways, this might be a good time to do it then. This can be written as a really nice identity like this. X cubed plus y cubed plus z cubed. And then to this, obviously, we're going to have the cubes, right, in this expression. To this, we can just add 3 times x plus y times x plus z times y plus z. In other words, everything besides the cubes can be factored in this sum. Great. So now, I do have an expression for x plus y plus z, which I use s, and then I know the sum of cubes. So I know a couple things here. So for example, this is going to be, it's given as negative 48, and this is just s, so we're going to cube it. That's going to become s cubed. But what about x plus y? I don't have anything for x plus y. I don't have anything for x plus z. I don't have anything for two-way sums. So we kind of have to do something about it. Let's go ahead and do that right now. So since I know that x plus y plus z is equal to s, from here actually I can isolate x plus y, subtract z from both sides, and I can write x plus y as s minus z. Notice that z doesn't appear in the sum on the left hand side. So similarly, we can write all of these like this can be written as s minus z, this can be written as s minus y, and this can be written as s minus x, because x plus y plus z is always s. Make sense? If you subtract one of the variables from the sum, you get the sum of the other two variables, in other words. So this is really cool, but we're going to make it cooler. So let's go ahead and distribute everything. Obviously, from here, we're going to get like 3 times s times s times s, which is 3s cubed, so on and so forth. So I'm just going to give it to you without further ado. We're going to get the following: 3s cubed minus 3s squared multiplied by x plus y plus z. So we're going to have a lot of different variables having the same coefficient, and then we have the 3s from symmetry, xy plus xz plus yz, because they're all interchangeable, and finally we're going to have minus 3xyz. Notice that everything is symmetrical, everything looks awesome. Okay, now what can we do about this? We can actually do a lot of cool things about it, because if you look at this carefully, x plus y plus z is equal to s, and negative 3s squared times s is negative 3x cubed. So this is like 3s cubed minus 3s cubed, that is a 0. Not only that, xyz is equal to negative 16, therefore we get a positive 48 from here, and these two also cancel out, leaving us with a single term, which is really cool. And we also have something for that. Remember, we found for xy plus xz plus yz s squared minus 24 over 2. So let's go ahead and plug it in and see what happens. We get s cubed equals 3s times s squared minus 24 over 2. Awesome. This is a cubic in s, so we can solve it, a single variable. So if you go ahead and multiply both sides by 2, you get 2s cubed. And if you distribute the 3s, you get 3s cubed minus 72s. If you put everything on the same side, don't just cancel out anything, don't divide by s, just put everything on the same side, and then you're going to factor, right? What am I going to do here? I'm going to take out an s, and this is going to give me s squared minus 72 equals 0. Yay, from here I get s equals 0, but I also get s equals plus minus square root of 72, which can be written as plus minus 6 root 2. Okay, let's not worry about the 6 root 2. Let's just worry about the 0 because that's the most interesting part. Now, what is s? What does s stand for? It stands for x plus y plus z. So now we know that x plus y plus z is equal to 0. We can also find xy plus xz plus yz from here, because remember, we had an expression for that here. Since s is equal to 0, that's just going to be negative 24 divided by 2, which is negative 12. And then we already know x, y, z. And guess what this reminds you, or this should remind you? Vieta's formulas. Yes, I've done a video on Vieta's formulas. You can check that out here. Okay, so Vieta's formulas tell us that if you know the sum, the product, and so on and so forth, you can write the equation. So we're going to use Vieta's formulas, which is awesome. So let's go ahead and use them. Suppose t represents x, y, z. So I can write the equation as t cubed. The sum is 0, so I'm going to skip that and go to the coefficient of t, which is 12, but we need to, which is not 12, negative 12, I'm sorry. So we're going to write it as negative 12t. And then finally, the constant term is going to be negative 16. But remember, that's the opposite of the constant term. Therefore, our equation is going to be t cubed minus 12t plus 16 equals 0. Now, we have two options here, either the cubic formula or rational root theorem. So let me go ahead and quickly show you how the cubic formula works here. I think we've done quite a few videos on cubic formula, and it's kind of fun. If you go ahead and take a look at this identity, a plus b quantity cubed minus 3ab times a plus b, that is equivalent to a cubed plus b cubed. And this is the critical part about our cubic formula. So we can replace a plus b with t, and then we can replace this with 12, and we can replace this with negative 16 because 16 needs to be on the other side. We're done, right? Well, we're done meaning we got a system from here. So a plus b is equal to t, 3ab is equal to 12, meaning ab is equal to 4, and a cubed plus b cubed is equal to negative 16. So this is a system, 3 variables, 3 equations. Let's not worry about this for now. Let's focus on these two first, because we can solve this. How? First of all, cube both sides here. Write this as a cubed b cubed equals 64. And then in the second equation, you can isolate b cubed and write it as negative 16 minus a cubed. And then you can go ahead and plug it in here, and that is the cubic formula in a nutshell. So go ahead and replace b cubed with negative 16 minus a cubed. That is equal to 64. This gives you the following. On the right-hand side, a to the 6th power plus 16, a to the 3rd power plus 64 equals 0. And from here, you can replace a cubed with c if you want. That's the usual way, but this is kind of obvious, hopefully. C squared plus 16c plus 64 is equal to 0. Guess what? This is a c plus 8 quantity squared. Therefore, we only got one solution from here. C equals negative 8. But remember, c is equal to a cubed, so we're going to set it equal to a cubed. And from here, we're going to find a equals negative 2. But since we only got one c value, and we know that AB is equal to 4, the product is 4, so B is also equal to negative 2. But remember, those values represent x, y, z. So T represents x, y, z, but we only got two values, negative 2 and negative 2. What about the third one? Here's the thing. You can go ahead and factor this equation like this. You can kind of write it as t cubed minus 16t plus 4t minus 16. I know it's not very natural, but if you know that t equals negative 2 is a solution, then obviously these represent, well, I shouldn't say a and b. Well, a and b, okay, one thing that I forgot to mention. Remember, t was equal to a plus b, so t is equal to negative 4 actually, not negative 2 here. Okay, a and b give us the value of t. So t is negative 4. Knowing that t is equal to negative 4, I can just factor it like this. Even though it's not the most natural method, you can also go off of this. T cubed plus 4t squared minus 4t squared and blah, blah, blah. You can proceed like that too. But I kind of find this more fun. Anyways, I can just write it like this. You can do it if you dealt with algebra before, like factoring. This is the difference of two squares. Go ahead and write it as t plus 4, t minus 4, and then 4 times t minus 4. In a nutshell, this just gives you the other two roots. Let's go ahead and write it down. T squared plus 4t plus 4 equals 0. And notice that t equals 4 is the one that we found from here, right, by adding those. By the way, this is supposed to be p minus 4. We are going to write it as common. It's supposed to be t plus 4. Now, how did I find... okay, yeah, I see my mistake. That is supposed to be a plus 16. There you go. I'm like, it's supposed to be negative 4, but okay, I messed up. Let me go ahead and fix this. So we take out t squared minus 16. Let me go ahead and do it real quick. T plus 4t minus 4. And this should be 4 times t plus 4. And when you take out a t plus 4, you should be getting t squared minus 4t plus 4, which can be written as t minus 2 quantity squared. We already know t equals negative 4 is a solution. But notice that t equals 2 is repeated. So we kind of have like negative 4, 2, and 2 as the solutions. And their permutations are just going to give us the x, y, z values. So we can kind of write it as two sets and set them equal to each other. And hopefully this will take care of it. But I know you can't repeat an element in a set, but let's just pretend we can. All right. So let's go ahead and take a look at the second method without further ado. Second method revolves around the following. It's a really nice identity, and as soon as you saw this system, it should ring a bell. What should ring a bell? The ratio of this and this. Notice that the ratios is 3. In other words, x cubed plus y cubed plus z cubed minus 3xyz. Now we know that x cubed plus y cubed plus z cubed is equal to negative 48. This is negative 16, and their product and sum is just going to be 0. What's that supposed to mean? Well, that is factorable. We can go ahead and write this as x plus y plus z. Remember that we used it before. Times x squared plus y squared plus z squared minus xy minus xz minus yz is equal to 0. And then from here we can get x plus y plus z is equal to 0. But also we have to take care of this. I'll take out a 1/2 and write the second factor as x minus y squared, x minus z squared, and y minus z squared. You can easily prove this, like multiply and divide by 2, and you'll notice that this is a sum of squares. But it's only a 0 if x, y, z are all equal to each other, which we know is not correct, because if you set x equal y equals z, then your system, original system, is not going to work, because you're going to get something like the cube root of negative 16 for one of the values, or x squared is going to equal 8. They're not going to match. So this is not going to be 0, and it's obviously greater than or equal to 0 because sum of squares. So this has to be 0. It brings us to the same point. But guess what? I'm going to proceed a little differently. Remember, in the first method, I used the, what is it called? Cubic formula. But this time I'm going to do something else. How about isolating one of the variables? I would like to isolate x. So I'm going to write it as y plus z is equal to negative x. And then I would like to square both sides. If you square both sides here, something nice happens. You get y squared plus z squared plus 2yz equals x squared. And now we can write an expression for y squared plus z squared. Why? Because we know that x squared plus y squared plus z squared is equal to 24. So y squared plus z squared can be written as 24 minus x squared. And that can be substituted here. So that gives us 24 minus x squared plus 2yz equals x squared. And if you put everything on the same side, you get 2x squared minus 2yz is equal to 24, meaning x squared minus yz is equal to 12. Awesome. Okay, what can I do with this? I can isolate yz from here and write it as x squared minus 12. That's really cool because I do know xyz is equal to negative 16. If you replace yz with x squared minus 12, you get the exact same cubic equation. And guess what? Without further ado, I'm going to give you what the solutions to this equation are. And those solutions are going to be x equals negative 4, x equals 2, and x equals 2. But guess what? These can also be like negative 4, 2, 2. That could represent xyz and its permutations. which you can again write as a set. And this brings us to the end of this video. I apologize for the lengthy video, but I had to present two methods and it kind of took a long time, even though I was kind of rushing through it. Anyways, this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.